just going to look at one type of equation today. Equations of this form, where you've got some multiple of sine plus some multiple of cosine equals a number. Then that number is not 0. Because if it was 0, not a problem. You could move the cos x to the other side, then divide by cos x, get a sin x and a cos x, becomes a tan x. When you've got a constant there, you can't do that, because the constant would also be divided by cos x, which then would create a sec x and doesn't solve your problem. We're going to look at two different ways of solving this. What we can do is turn our trig equation into a polynomial equation, or more specifically a quadratic equation, by using the t results. Remember, the t results will change the trig into algebra. So if we use that idea, so we'll use this example as an example. 3 cos theta plus 4 sin theta. So if I use the t results, with t representing tan theta on 2, then the equation becomes this algebraic equation, so 3 outside of 1 minus t squared and 1 plus t squared, plus 4 outside of 2t and 1 plus t squared is equal to 2. But note, I'm only going to look for solutions in the first and the second quadrant, because now I'm solving for theta on 2, not just theta. So we're only interested in first quadrant answers, second quadrant answers. We'll multiply everything by the 1 plus t squared. Let's get rid of the denominator. So we've got 3 minus 3t squared plus 8t. Move everything to one side and make it look like a quadratic. So there we go. 5t squared minus 8t minus 1. I don't think that one factorises. So we'll go to our quadratic formula. 8 plus or minus root 84 on 10. That does simplify to be 4 plus the square root of 21 on 5. 4 minus the square root of 21 on 5. Remember, we're only looking for first and second quadrant answers. So the question we have to ask ourselves is, are we looking at a negative number or a positive number? 4 minus the square root of 21 on 5 is a negative number. So we're looking for an obtuse angle here. If we go into our calculator, we'll end up, well, the acute angle, if you want to do it that way, you do your equivalent acute angle, which would be root 21 minus 4 on 5. It'll come up with 6 degrees 39. However, if you just do 4 minus root 21 on 5, you will still get the acute angle, but it'll give you the negative acute angle. Okay. Either way, we want the second quadrant answer. So it'll be 180 minus that acute angle, 173 degrees 21. That's what theta on 2 is equal to. Multiplied by 2, we get our answer for theta. Okay, let's go look at the other one. 4 plus the square root of 21 on 5, well, that's a positive number. So we just want the acute angle, the quadrant 1 answer. We go straight to our calculator. That's 59 degrees 47. So theta on 2 is 59.47, which means theta is 119.33. So we have our two possibilities. However, what we have to watch out for if we're using this method is the possibility that theta equals 180. Because if that is a solution, the t results will not find it. Why? Yeah. See, look, we're letting t equal tan theta on 2. So if the answer is 180, t will represent the tan of 90, but tan 90 is undefined. So it won't be able to find that answer. So if you're using the t results, you need to check to see whether 180 is a solution. Now in this case it's not. Cosine of 180 is negative 1, sine of 180 is 0, so negative 3 doesn't equal 2, not a possibility, so no. And I've somehow done my maths wrong over there, because I've ended up with negative 4, not negative 3, but either way it's not equal to 2. Okay, so there's my two answers, 119.33, 346.42. That's the way people feel really comfortable with, because it just turns it into a quadratic, and people like solving quadratics. However, there is a much neater, nicer way of doing it. Your initial reaction will be, no, I want to use the t results. Because as I say, it'll go to a quadratic equation, you'll feel comfortable with that. But what we can do is what's called the auxiliary angle method. It allows me to, when I have sine and cos, to change something which is two trig functions into one trig function. I'm going to change it into a sine function. So there's 3 cos plus 4 sine. Now how do I change it into a sine function? It uses our sine cos sine idea. And so I look at this and I say, well, sine cos sine, I've got 3 cos 4 sine. So what that's saying to me is, well, sine theta has got something to do with the 3. Now sine is the opposite side. So I'm going to put 3 on the opposite side of my triangle. Okay, sine cos, well, cos 4. So cos has got something to do with the 4. So I'm going to put 4 on the adjacent side. By Pythagoras, I can work out that's 5. So what I now can do is change this question. Because 3, of course, was not the sine of alpha. If I look at my triangle over there, the sine of alpha is 3/5. So what I would have liked there is 3/5, not 3. The cos of alpha is not 4, but it's 4/5. So what I would have liked there is 4/5. Well, I can do that if I multiply by 5. So I actually now have got sine alpha cos theta, cos alpha sine theta, which is sine of alpha plus theta. But I got 5 times it in this case. So the hypotenuse, you'll notice 5, it will always end up being the coefficient of my trig function in this equation. So the hypotenuse will always go there. And what I now can solve is sine alpha plus theta is 2/5, which is a simple little trig equation to do. Sine, it's 2/5. So I know I'm in the first quadrant. Oh, but hang on, I need to know what alpha is. I can go back over here and use this triangle. Tan of alpha is 3/4, so alpha is around 36 degrees 52. Okay, back over here. I know it's in the first and second quadrant. The acute angle would be, well, let's work it out, 23:35. So alpha plus theta, 36 degrees 52 plus theta, will be 23 degrees 35, or in the second quadrant, 180 minus that, 156.25. If I subtract 36.52 from both, I come up with the answers negative 13.17 and 119.33. One of those answers is the same as we got. One of them is not. Minus 13.17. It is the right answer. It's just that it's negative 13.17. We were looking for answers in between 0 and 360. So if I go round the circle again, add 360 to the minus 13.17, we will get the other answer of 346.43. And there's the 2 answers. Yeah, I can see people thinking, no, I'll just use T results. That was nice and easy. But the idea of putting 2 functions into one becomes really, really useful when we start looking at things next year of simple harmonic motion and things like that. It can make questions so much easier. Let's do the same question, but this time instead of turning it into a sine function, I'll turn it into a cosine function. So the same numbers, but this time the pattern I'm looking for is cos, sine, sine. So I look at it and think, well, hang on, 3's got something to do with the cos alpha, so my adjacent side will be 3. Sine's got something to do with 4. Opposite side will be 4. Once again, the hypotenuse is 5. So I got 5 lots of 3/5 cos theta plus 4/5 sine theta. 5 cos, remember, if it's not the sine, it's not the sine. Theta minus alpha is 2. Once again, the hypotenuse, you'll notice, is the coefficient. So the cosine is 2/5. This time, we'll get a different answer for alpha now because we've swapped the 4 and 3 around. This time alpha turns out to be 53 degrees 8. So I'm in the first quadrant and the fourth quadrant. The acute angle is 66.25. So theta minus 53 degrees 8 is 66.25 or 293.35. Add 53.8 to both and we get the two answers that we were looking for. In the HSC though, because sometimes you can't avoid it. Because here they've specifically asked you, hey, actually turn these two trig functions into a single sine function. Alright, sine function. Sine, cos, sine. If you think about it, sine 3t cos alpha minus cos 3t sine alpha. There's my triangle. Cos is the root 3, so I'll go adjacent. Sine is the 1, so I'll go opposite. The hypotenuse becomes 2, so that's equal to 2 sine 3t minus alpha. There's my answer, except I've got to work out alpha, of course. I'll look at my triangle over there. Hey, it's an exact value. You'll notice 1 over root 3. Tan of what is 1 over root 3? 30. So yeah, there it is, 2 sine 3t minus 30. Try another one. This time they said, turn it into a cosine function. Okay, cosine would go cos, sine, sine. Oh, hang on. I've got sine at the front. Well, I'll just swap them around. Cos minus sine, sine. So I'll factorise out a negative. It'll make life a little bit easier for myself there. So now I've got a cos minus sine. I'm happier. So cos, sine, sine. If I draw it in, well, both the opposite and the adjacent will be 1. The hypotenuse is the square root of 2. So I get minus root 2 x plus alpha, sorry. Exact value again. Tan of what is 1? 45. So I get minus root 2 cos of x plus 45. Have a go at those out of 2e. As I say, I know you're going to feel more comfortable to start off with using t results, but have a go at those auxiliary angle ones. Once you get into the hang of it, hopefully you'll find it a quicker way of doing it.